class. In this tutorial, I'm going to show you what we need to do for problem 12.18, simple chi-square test, because we have 3 or more groups or categories of data. So a simple 2x2 contingency table and chi-square test is not enough. So, using our handy-dandy PHDAT2, which provides us with a nice, simple, easy-to-use worksheet, we can run this test and the subsequent Marashilo procedure to test for the various combinations of our categories of data. So, we go to multi-sample test, we go to chi-square test. All it's going to ask us is for a few pieces of information. We'll use a p-value of 0.05. We have, let's stick with 2 rows and 4 columns. We want to check the box for the Marashilo procedure, give this just a quick title of the problem, and click OK. And basically what we're going to get is a little worksheet here that we just plug our data into. So you can just type your numbers in here. I have this done, so I will just copy and paste here. And it will do all the work for us. Ta-da! Now you should know you can relabel your columns here. Unfortunately, though, when we look at the Marashilo procedure, it doesn't carry over those labels. It only does it on this particular worksheet. So you have to know which rows and categories for each column as well correspond to one another. So in this particular example, we have a 2x4 contingency table. If we look down at our p-value, it is less than 0.05. Our calculated chi-square is greater than our critical value. So we will reject the null hypothesis. It's basically just saying there are differences amongst the various categories and combinations of rows and columns here. But since we have multiple columns here, multiple categories, this is where the Marashilo procedure is necessary, and by virtue of checking that box, it automatically gives us the output here in its own tab, in which you can basically see what it does here. It compares groups 1 to 2, 1 to 3. It does every combination and tests the difference between the two and tells you if it's not significant or significant. So in this particular example, we have 2 significant combinations and 4 that are not. That's it.